Hello, chat. Season's greetings. I am drinking tea this fine morning. I hope you are having a very good afternoon as well. I'm very happy. 12 p.m. Central Time to you. All right. I'm gonna try to bump it up a bit. Yeah. I've been trying to nail it down, kind of all this morning. Not really, but yeah. It doesn't seem to be working right now. Is the gain a bit better, or do I need to turn it up more? Okay, I just set it to 2.5. Hopefully that works. Okay. Yeah, I have the chat box in there. Yeah, I can try that. Yeah, I'm not the only one streaming Ocaml. We're gonna raid their channel after I'm done here. But yeah, the chat. Wait, hold on. So that it's updating the changes. Maybe, I don't know. But yeah, no, I have the chat box set with like a theme just set to the default. Maybe the extra emotes is making it not work. Browser settings, refresh cache. Yeah, I don't know. I don't know too much on how to make that work. I don't know. I'm gonna try to improvise here. Maybe we can get that going. Yeah, I don't know. So I've deleted it, re-added it. Apparently there could be an issue with browser acceleration, but I would have to restart the program to do that. So I'm wondering if I should try that or if I should just keep going. Oh no. Oh, the VM's falling asleep. Oh, well, I think I'll just write a couple functions and then maybe I'll do that. Yeah. The slow sleeping. Yeah. Yeah. Well, that means we get to write a function named dex that applies a function named dec of type int applied to int to each element of an input list. Yeah, so Ocaml is a functional programming language, and this here is a big old document of 114 different functions, but you know, there's kind of a pattern here. So I was going to just write a few of those and then just fiddle with that, work it out. Ocaml uses ML files, and the sort of REPL is called utop, so you can punch in like expressions like into utop, or you can load them from a file, which I'm going to do. It's very good. So our first function is dex, not to be confused with gex, and that relies on a decrement function, and I can just write that let dec, and then I want to take in a integer type. So that's I int or n int. I'm just going to call it n for number, and then that's going to return an integer, and that's just going to be the number that comes in subtracted by 1. So then if I reload here, it'll tell me that it's loaded that function, and then I can just use it, you know, any way that I want. So gex enter the camel. I really wish the chat box was working because that's great. That's great. I appreciate it. I appreciate you all. Thank you for taking time out of your busy days to be here this morning. Not morning, but this evening, this afternoon. And so a function named dex is going to take in a list. So that's actually going to be a recursive function. So we're passing in a list here, and that's going to be an int list. Yeah, I appreciate it. I'm glad to know that I'm happy to know that I have a fan base. So this is gonna require some pattern matching, and pattern matching is great because you can match things within the list. So we're gonna match ns, which is our integer list, which is going to be a list of integers. If you want to know what that's going to look like, here's a list of 4 elements, 4 numbers, 4 integers, 1, 3, 3, and 4. I was trying to write 7, but I wrote the wrong one. But so our base case here is going to be an empty list. Yeah. So if you pass in an empty list to this function, it's only going to return an empty list back. And then our other thing is we need the number, of course. And then n is going to return n, no, the decrement of n, cons, so like prepended, so it's put to the front of the list. So, and then dex. Oh wait, whoops. Okay, I'm just gonna do x cons xs. So this actually, you can frame it like this is the head of the list. This is the tail of the list. So the head of the list is going to be the first element in the list, and the tail of the list is going to be like the rest of the list. So the decrement of n cons with the rest of the list, but applied to this function. So you see it's going to call itself for every number in the list until all of the numbers have been decremented by 1. Yeah. 1. So if I reload my file, yeah, I do. I'll export it to YouTube after the stream. But the chat's gonna be like lost, so maybe I'll have to edit it in. I don't know. I might work on that after we test our delightful little dex function. I think I'm gonna try to fix the. I don't know. That would involve restarting the stream because I have to restart Streamlabs OBS, or I'll just try to do the wonky like browser source way of doing it, which would probably work better. So we give our dex function. Wait, did I save it? I had to have. Unbound value n. Oh yeah, because I wrote the wrong. I mean, I wrote n over here and then I replaced it with h, but I'm just gonna say head and then tail, and that'll make all the sense in the world. So our decrements function, 5, 5, 5, 5. Go away. No, you can get the best viewers on that website at Sepia Web. 1, 2, 3, 4, and it decrements each of them by 1. So this is our first function of 114. Okay, I'm going to switch to a quick break while I try to figure out the chat, and then we'll be back and we'll write some more functions. And we're back. A bit scrappy, but it should get the job done. Let me actually let me crop the title a little more. Yeah, something like that. Yeah, okay. I'll just leave it like that. Oh no, it's going to sleep again. It's going to sleep again. Alright, I gotta punch in my very secure password now. And we're on to function number 2 of 114. Okay. So this is similar, but our requirements here is to write a function that decrements all the elements of a list that are positive. Wait, no. It decrements all the items in the list and then selects the resulting values that cause the function positive to return true. So I'm going to write the positive function, and this is just going to check that a number is positive. So we're just going to ask for a number and then return a Boolean, if I can remember what Booleans are in Ocaml. And this is pretty simple. It's just going to be an inequality that's is n greater than 0, greater than or equal to 0. Wait. Man, are 0 values positive? I don't know. I'm just going to say values that are greater than 0. Because on the actual quiz, I'm not going to have to write positive. That's why this bit is here. But, I mean, I'm still writing it anyway. So, our dec positive function is going to be another recursive function. It's going to take in a list in a similar manner to as before. And it's going to match the list. Empty list is our base case. Head cons with the rest of the list, which is a tail. And I can actually use the when keyword here. When dec head, when positive dec head dex dec positive, yeah, tail. So the when keyword here is like, oh wait, no. Okay, I need to then also match when the decremented version of the head -1 is not positive. So I also match just a regular head to tail where I just continue on through the list by calling dec positive again. So then I should be able to reload and, yeah. So it's bool. Yeah. Awesome. So then I'm just going to give it a list 1, 2, 3, 4. And so what happens here is it decrements each item in the list. So 1, it subtracts 1 to get 0, and then it notices that 0 is not positive. I mean, I can assume that 0 is positive. Let me do that, and it'll be similar. But so it decrements each of them by 1. But if I give it like a negative number in here, it's not going to keep that number after it's decremented it by 1. I really love the when keyword. I kind of misuse it a lot, I think. but I think it's fun. I think it's quite enjoyable to write functions with the when keyword, and because head isn't really used here, I can just match it with an underscore just to tell Ocaml you should just discard this. It doesn't really matter. I'm not putting a name to it. So for each element in this list, it's going to check if the positive version of that that -1, and this deck head just like translates to n-1, because I'm not calling that function, but I'm using that function. And that returns an expression, and it's using that expression. But if I, if I load my stuff again and recompile it with head -1, reuse it, and then run my deck positive function, it's just gonna do that. So yeah, that's how that works. And then we have another similar one. All of these are kind of similar. But we have write a function named inks that applies a function named inc, or increment, of type int, gets applied to int. Whoops, opened the HTML file accidentally. I have a preview of it. To each element of an input list containing values of type int. Yeah. Oh wait, I scrolled up. But this is the same deal. This is the same deal, but it's just incrementing instead of decrementing. So I'm just gonna copy and paste this here, and there you go. So here's our increment function. I run inc4, and it gives me 5. And then I run my inks function, and I give it 420, 700, 9001, and it gives me 421, 701, and 9002. So moving on, negate odd. So it applies the function negate to all elements of a list, and then selects the resulting values that cause the function odd to return true. Okay, so I'll write the negate function, which is just going to I would assume it's going to multiply it by -1 to make it a negative number, or a positive number if it's already a negative number. So negate odd, nope, I'll just write my standard negate function, and that's going to be n times -1 point. Nope, it's an integer, so I don't need to do a special thing. You see, the operators in Ocaml are a little different if you have a decimal. So if you're trying to multiply a decimal number, you can't use an asterisk. You have to use an asterisk and this period here. And that's the same thing for subtraction and addition and dividing. But we're working with integers, so it's really easy in our case. So that's my negate function. And then I need an odd function. And that's going to check if it's odd. So it takes in an integer. Oh, wait. I want this one to return an integer. You don't technically have to do this in Ocaml. It can sort of figure out what you're trying to return because the type system is so gosh darn good. But I'm still doing it because it's good to know these things. So it takes in an integer and it returns a Boolean, and it's actually just going to return whether n mod 2. So taking the modulo of n, and that's going to be the remainder if you, it's the remainder part if you divide it by 2. So n mod 2 equals 1. So this is the remainder. So if you divide n by 2, it's going to give you is going to give you 1 as the remainder if it's an odd number. So numbers like 1, 3, blah blah blah. So let me just test this function. Not 99 problems, as cool that would be. So it tells me that 2 is not an odd number, 3 is an odd number, 0 is not an odd number. And then negate odd. Whoops, I did that again. It's going to be another recursive function. So negate odd. ns int list. And that's going to return an int list. So for everything in the list, it's going to match first the base case. So you give it the empty list, or if it when it runs into the end of the list, you know, it's just going to spit back out an empty list. And head, tail, and this is just going to be like, I'm going to write another one above. Head, cons tail, when odd head, and then negate head, cons negate odd. So it's calling itself again, tail. And then I'll just, if it's not, you know, in other cases, it'll just cons the head back to the rest of these function calls. Then I'll test the negate function just for fun. You know, you give it 5, it gives back -5. You give it -5. Oh yeah, you need to surround it by parentheses for a negative number. Otherwise, it confuses it with the actual like subtraction operator. That's a function in Ocaml. So negate odd. So I'm gonna give it some odd numbers and some even odds, and so even numbers. 8, 9, 10. There you go. That's wrong if I wrote the right function. So you notice that 0, I mean, not that it would change anything because 0 is just 0, but that's not negated. But 1, like 3, 5, 7, 9 are. So that's cool. And yeah, if I were to just write negate odd, it's going to tell me that it's an int list applied to int list function. I'm pretty sure when you're pronouncing these the arrow things, it's applied to or has the type or something like that. All right. All right. So doubles. NS int list. Match NS with empty list. Turns to empty list, and then there's no condition here, so it's just, you know, the head, which is, you know, the number that we just get, and then, you know, const with the rest of the list, or, you know, you match n const with the rest of the list, and then it's just n times 2, or actually, you know, Let double n of integer spit back out an integer, n times 2. Yeah, there you go. And then double n columns with ns. And then that's our doubles function. Doubles. 1, 2, 3, 4, 5. I don't think that's what was supposed to happen. Muy curioso. That's interesting. Yeah, weird. So, oh yeah, I forgot to call, I forgot to feed it back into the function. Forgot to do tail recursion. Yeah, because why that happened is that, so it would double the first one, but it would just cons it to the rest of the list that was like given. So it wouldn't feed it back into the function, and it has to get fed back through the function for the tail recursion to work. So then we have our doubles function. Very cool. And then code is square. All right, first applies the function code to all elements of a list and then selects the resulting values that cause the function is square to return true. Code returns the ASCII character code for a given character. Its type char has the type int, or to the type int. I don't know. Applied to the type int, something like that. Do not need to write code. May assume that it exists. Yeah, cool. And then is square determines if the integer is the square number. Yeah, so is square could be let is square an int cool, then if n times n determines if no, is square might be a recursive function. Not too sure here. I'm trying to remember. Because squares would be like, okay, if you can find one number and find a number that doubles. Okay, let me do some tomfoolery. And just see if that up. I wrote this function before, so I should remember how, but it's a little trickier, I think, since we're writing a function inside of this function, and then we like stuff, and then in add up from. Oh wait, no, I think we can like count down, and then match with no worries. Why am I matching it like a list? I shouldn't be matching it like a list. I shouldn't be trying to match an empty list for a number. How silly. And when n times n equals n. And that would be true. Yeah. And then match it with 0. It would be like false or 1 or something. I don't know. This might work. This might work. It'd be really funny if it did. Partial match, so it's not matching 0. Let me just do 0. Apparently 1 and 0 are different cases. Well, wait, yeah, well, 1 would be the square of itself. So, very keen of Ocaml to catch up on that. Catch on to that. Case that's not matched, 2. Oh, wait. I should just do that. I shouldn't use the when clause there. Redundant. Wait. I don't know if I'm writing the right problem. I think I bungled it. I think I bungled it. Because like 25 is a square, because 5 times 5 equals 25. So what I'm trying to do is count down from the number to find a number that's... Actually, no, I don't know, I should keep counting up from 0. That would be more efficient. Count up to 0. And then, okay, search. I'm gonna call this search. And then start to find square, no, n, no, wait, I can just access n from there. Okay, all right, match, start with right. Sorry, I need to think. Let Rex search, start, and then do something with start plus 1, no. Match start with start when start times start equals n, true. Start, search, start plus 1, since we're starting from 0. And then when it like gets up to, oh wait, no. Start when start times start is greater than n is false. So like if you're looking for a number, like if you want to check that a number like 26 is a square, then what the program is going to do is it's going to start from 0, right? And it's going to multiply 0 times 0 to get 0, and it's going to be like no, and then it's going to go further. And it's going to try 1 times 1 equals, and then like it's going to get 1, and then it's going to try 2. 2 times 2 equals 4, and it's going to try 3. 3 times 3 equals 9. 4. 4 times 4 equals 16. So it's going to keep squaring numbers until it either finds, a number that's equal to it, and at which point it's going to say, yeah, it's a square number, or the number provided up here is a square, or it's going to cross that, and then it's going to get 36 here, and it's going to be like, oh, that's larger than n, and then it's going to be like, no, you can't do that, and then, it's going to return false. That's how it's going to check. Count up. Yeah, search. I'm just going to call it count. I'm going to call it count. Whatever. But that's the that's the helper function. So is square. We'll test it. See if 0. So 0 times 0 equals 0. So yeah, 0 is a square. But and then check 25. 5 times 5 equals 25. So it's going to return true. Something I should have been doing probably is one thing that you can do. I'm going to just open up my solutions to 99 problems here that I've been working on, and you can assert that something is equal. So that's a very easy way to test functions. So this let underscore equals assert is square, 25 is equal to true, and assert is square 64. 8 times 8 is 64, so it should be able to find that. And then try is square 14, because that's not a square. And here's another number that's not a square. 21. And there you go. There we go. Yeah. So these tests are passing because it just returns unit. If I were to try to assert that 20 is square 21 equals true, it's going to fail that because that's not what the function returns. So assert failure. So if my function is not working and my tests are correct, it'll tell me when I load the file. So and then code. Yeah, there must be a way to get. Oh yeah, int of char C, and then that's gonna return the ASCII code. So this code function that I speak of is just int of char, or it's just an interface for int of char. So take in a character and return an integer, and that's just int of char C. Yeah. All right. Yeah, why not? Why not write a negates function? Because it's just. Oh wait. Oh yeah, I can write code is square. Let me write that first. Code is square. And because I already wrote this function, or these two functions, it's gonna be pretty simple. So chars, char list, it's a list of characters. And then replace or int list. Turns an int list. Okay. applies the function code to all elements of a list, and then selects the resulting values that cause the function is underscore square to return true. Yeah. Okay. So match chars like we did before with empty list, and then C. Next. When is square code C. Yeah, so when the ASCII code of the character that we run into is square, we're going to include that as part of the list. So it's going to be C cons code is square next. Otherwise, it's going to just go onward, match the rest, continue matching the rest, appending that to the list. That's what I thought it would happen. Expression is expected of type int, right? Yeah. Code C. Yeah. Code is square. Oh, it is a recursive function, so I need to tell it that. Code is square. Now I don't know any ASCII characters that are like that their codes are square at the top of my head, but off the top of my head, but I'll just, throw some in here and see what happens. Whoops. And yeah, it looks like none of those are square. So wait, char of int 64, that's a built-in function. Okay, yeah. And then I'll just stick in an address line in this one, and then a couple others, and then yeah, it keeps. Oh, apparently D is also D's code is also square. Yeah. No. Yeah. It's very good. It's very good. I appreciate that you're tuning in. I know it's not like super exciting or anything, but I might wrap up with this stuff pretty soon. Because it's Ocaml function hour, and the hour's almost up. Almost up. I just need to figure out what I'm going to do for the rest of the stream. And while I do that, I'm just gonna write some more functions. This is studying for my quiz. I'm just studying for my quiz. I'm using a stream as an excuse to study for my quiz. And this is before any higher order programming. There are functions for filtering and mapping functions to like a list or something. I'm not doing that. I'm just writing recursive functions right now because we're not to that point in the course yet. All right, so negates function. It's a real, muy fácil one, because int list, and then we're just gonna match ints with always remember our base case, which is gonna be an empty list because it's just gonna be like keep funneling through until it gets to the end of the list, and then next is going to be equal to negate I. Consed with that tail recursion as before. Yeah, so just feed in some numbers and stuff. I don't know, and then it just multiplies them by -1. In fact, you know, I don't really see a reason why one would write a function for something as simple as multiplying a number by -1, but you can do so, and that's awesome. Here's just an alternative version. So in Ocaml, when we're writing like an alternative version of a function, people will usually add like this little apostrophe, not apostrophe, like this little tick at the end, this prime. So it's negates prime. So, and then you know, this version of it, I can just, you know, multiply by -1. And, you know, if I wanted to get real fancy with it, hold on. And if I wanted to write it in as for doubles, and doubles are going to be like decimals, so double list, I'm going to return a double list. This is going to be negates prime prime, I don't care. And then as I mentioned earlier, I need to add the dot next to the asterisk for my multiplication operator when I'm dealing with decimals. Then I can use unbound type constructor double. There's some type for for decimals. I don't think in this entire list of oh man, first letter is a letter. That's funky. But no, I think I could. I don't think I need to write many more of these functions. I just need to like I need to look up. Oh wait, no, I can just do that in UTOP itself. Oh, it's a float. It uses floating point number. Yeah. Okay. It doesn't have a double. The floats, float list, and then yeah, then I can. No, floats. Right, there. Types have to match up. And then, yeah. Yeah, so it just, yeah. And then that just does that. Is letter. I'm sure if I had to write is letter, it would probably be converting the character to an integer and then doing something, checking if it's in between a range for sure. Oh no, I need to hold on. Fixed. I don't know, it just falls asleep. I don't know why. Boom. Bingo. Bango. Bongo. Now we're really cooking. Yeah. Yeah, it's true. It's true. So, yeah. It just keeps happening. I'm out of tea. But I have plenty of water. Which I need. Sorry, that's... I guess it like decides that because it's in the background and because I have other things going on, it's just like, no, this isn't important. It's like, man, I would like to, you know, have it work. I would love for it to work. Maybe by the next time it'll work. Hopefully. Okay. Just to challenge myself a little bit, I'm gonna try writing that isLetter function. So isLetter chars, yeah, sleepy chat. I'm just gonna have it off to the side, so whenever it like stops working in the preview, I can just like click it and then like, why is that stuck? Okay, never mind, we're good. All right, char, and then it's supposed to return a boolean. Yeah, no worries. Don't let me get in the way of like work that you're actually paid to do. All right. Clearly more important. Look, it's skill building. All right, so isLetter, so match char with C, just return C. So what the, no, just return false. So any other character, it's gonna return false, and then I'm gonna write some special ones for with characters that are in certain ranges. And I'm pretty sure, if I remember how ASCII works, the lowercase letters and the uppercase letters just like follow each other. So if I were to go int of character to get the code of like lowercase a, and then I get the character of lowercase z, see 97 to 122 is the range between those two. And then I get capital A and capital Z. Okay, so no, I was wrong. So there are two distinct stages, or no, ranges. So actually, I can match my code function that I already wrote that basically just uses int of char. So it's like, why, I don't know what the point is of using that. So it matches the code of the character, the ASCII code of the character. It matches the ASCII code of the character with oh wait, okay, no, okay, underscore, because the one is not important. It just has to be in some range. So underscore when no x, when x is greater than or equal to 97, and unless I write out and, I think I need to write out and x is less than or equal to 122, and then I'm just gonna write a comment on the side where it's like, okay, lowercase, I'm going to return true, and then x when x is greater than or equal to 65 and x is less than or equal to 90, that would be an uppercase case, but for the purpose of this function, it doesn't really matter. I just need to get both ranges in order to be able to check that it's a letter. And then I'm gonna write some like tests for this. So like I'm gonna, is a letter, and I expect that to be true unless like somebody the Unicode folks decided that a wasn't a letter anymore, which they probably could do that if they wanted to. So A's got to be true. I got to check the beginning and end of the ranges for sure. So I got to check these things that definitely are letters, right? No need. Right? And then check some things that aren't letters for funsies, just to see that this function works. It's gotta work. It's gotta work. There's no way I could have made a mistake. Okay. I made a mistake. This unmatched. What happened with my format? Oh. I don't know why I was using the arrow operator there. It had to be equality. It's an equality check. We're good. Oh, I went a little over. But anyway, Ocaml functional hour is just about over. I might do something else. Char list. How could I do this? Wait, why am I looking for a list? Okay, wait, no. Okay, match C. No. Okay, C. Okay. There we go. And the function works. So my is underscore letter function takes in a character, which is C, and then it returns a Boolean. So it matches and matches are kind of like fancy if statements. So int of char, int of car. You know, I've heard it pronounced both ways. I don't know the proper way to say it, but integer of character of C. We take that and then we match it with these patterns. So when it's greater than or equal to 97 and less than or equal to 122, which is the range of lowercase letters, yes, it's a letter. Then we do that with the range of uppercase characters, uppercase letters, and we return true. And in all other cases, we really don't care. We could, you know, get X here, but we don't use it in the expression after. So we just put down an underscore because we don't care very much. So, and then that just returns false. All right. So that's it for Ocaml function hour. I need to figure out what I'm going to do next for the rest of the stream, because I'm gonna be streaming until I did get the high score. I'm very proud of it. I need to refresh the chat again. Yeah, there we go. I did get the high score. I got 100% because all my tests are passing, even though I wrote like 2 of them. So now I get to play solitaire. And no, I'm not going to play solitaire. That's going to be frustrating. I'm going to play... Oh. Maybe I should play solitaire. I put solitaire as the game on the stream, like, before I changed it to science and technology, but I almost had this version of solitaire as the game, but I don't know. Solitaire is gonna take a while. I don't really want to play solitaire. Let me play something on Flashpoint. I'll just find something on Flashpoint and we'll like play that until I'm like done. So I'm gonna figure something out. And it's not going to be Peggle. Yo, I should play Zuma. Yeah, I should play Zuma. Zuma would be a good bet. Very good bet. Which version of Zuma.com do I play, though? There are so many of them. There's a Flash version, there's a Flash version, there's a PopCap player version, there's a Flash version, but it's also from King.com. Which one do I choose? I think the King.com one looks like pretty recent. So I might just try that out. Might try that out. Oh yeah. Yeah, I'll just capture this window. And then when people are looking for Ocaml streams, they're gonna get Zuma instead. Ocaml fanbase is in shambles. I masquerade as a big fan of their little game. Oh yeah, okay. Great. Gonna turn on desktop audio. It doesn't look like we get music, but we sure get sound effects. Let me know if it's too loud or too quiet or something, even though there are just like a few sounds. Alright, I'm already screwed. It's bungled forever. It's only the first level, so there's some room for error here. Now, one snag is I'm not sure how to switch the color of the ball. If I remember, there's a way to do it, but if I right-click it, it just pulls up the flash settings or the flash context menu, and that's not ideal. That's not ideal at all. Yeah, no. This is actually Ocaml 6. I got a limited access beta version of it from the wonderful Ocaml team, and it looks like this now. So each ball represents a function, and the ball reflects an expression. All right. I haven't played like Zuma Deluxe in like what feels like years. Such a good game. It's a very good game. Ah, yeah. Whoops. ×3 combo. It really does. Yeah, I know. It has that feel to it for sure. And I was just saying I thought I should be able to switch the colors, but when I right click, it just pulls up the flash context menu, so I don't think that works. Unless there's some other way to do it. Unless it's just been that long since I played Zuma that I don't remember how it works. But I thought there was some way to switch it between the next ball and the one that you have. Accuracy. Ah! I'm gonna get that coin. I'm gonna get the coin. Oh wait, I'm gonna get it. Got it. Let's go. Can we get some hype in the chat? So good. All right. Oh, screw it. Yeah. I love to see that enthusiasm. Yeah. We are winning. We are so back. It is Wednesday. No, it's Tuesday. Sorry, that took me like a minute. or at least like 5 seconds. But, you know, I'm manifesting Wednesday. I think Wednesday is going to be pretty darn good, really. I have high hopes. Especially if today's anything to go by. Today's great. Yeah. And again, the audio is okay. Can you like barely hear it, or is it okay? Oh no! 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 I guess in this version, I would assume in this version, I think it's bungled. I think it's not worky. All right, well, let me just play. I'm gonna play another version of Zuma, and then we're gonna see what that looks like. Open this up again. Ah, I didn't even have to edit the thing because it's running in the same sort of browser. All right, well, I should. I don't know. I don't want to mess up the thing too much. Unless I can. Oh. Yeah, there we go. I don't know what. Wait. Huh. Why is it just the mushroom? I guess it must be some vine sauce. Yeah. It must be some. Whoops. Sorry, the chat just like was slow again. It must be some like thing with the PopCap player where it's like it like it's just a separate window, maybe? So I'm wondering if I can add another source and then like match the... No. It doesn't look like there's a way to do it. All right, so we're not going to play the PopCap play version of Zuma. Sorry, everyone. I know you were looking so forward to it. But let's try the, I guess, this older Flash version. Should work just fine. Maybe? Why isn't it working? Let me reconfigure this. Oh, now it works. It just like... Yeah, let me update it, sorry. It's gonna work. It's gonna work. I guess when I close the window and open it up again, I need to recapture it for it to work. So... All right. Level 1. Oh man, it's a lot smaller. A lot smaller than the last one. And that's not me just not resizing it. It's a fixed size. I love chain bonuses, combos. Yeah. Uh-oh. Oh no. Yeah. 1, 2, done. Time for 1, 3. Let's go. Yeah. No! Why did I miss that? I'm so mad. Yeah! Alright, 1-4. Whoops. Gap bonuses. Boom. Alright, 1-4. Is there a 1-5? No, there's not. Alright, get the deluxe version. You all running out to the stores now to buy the deluxe version? Hope so. Cause it's good. You should buy Zuma Deluxe and definitely not pirate it at all. No. Very good game. Very good game. Big fan. Big fan. I could probably squeeze in some bloons, I bet. I think. Would you guys be into that? Just bloons for the rest of the stream? I don't know. I'm at a loss of ideas here. Like yeah. I wish I had my capture card set up to the PS2, then I'd be able to like play some Tony Hawk or something, but chat's frozen again. Arg. Yeah. Yeah. I need to make sure that's not broken. Yeah, no, and I'm pretty satisfied all together. Yeah, I'll just do some balloons. I'll do like 1 or 2. I mean, I don't think they're like super long. Might be like 20 minutes or something, and then I'll call it. All right, let me get that working. Or remap this to the... Yeah. All right. Now this one is especially important that the audio is set up correctly. I'm gonna do one of them that I haven't done before. which might be this one, 3 times around. If chat, if you have any suggestions, now is the time to do it. But I'll probably keep the beginner ones because I haven't started with the intermediate ones yet. So 3 times around. I'm kind of feeling 3 times around. Kind of feeling 3 times around. Yeah, I'm gonna do 3 times around. Gotta throw the chat open to the side again. All right. Okay, so first things first. I'm gonna start with boomerang. E. Yeah, let's start with an upgrade. I gotta plan this out so carefully. Easy peasy. Muy fácil. Drawing. Drawing is good. Oh my goodness. I couldn't have put this in a worse spot. I don't think. Because I could have put it around... I could have put it in the center. That's where my next one will be. Alright, okay. We're good. There's room for, like... Maybe I'll put a super monkey there when I get to it, but... It'd be a good bit. It'd be a good bit. Yeah, that's right. Yeah. That would be beneficial. That would be beneficial. Be a good idea. Oh! Dart monkey. Alright, do I buy a dart monkey or do I glue gunner or do I upgrade? Buy a glue gunner. Glue soak, figure glue, buy another dart monkey. I'll buy stick him here. Wonder if I should change the stream details, but I mean, since we're winding down anyway, there's no real point to it. Just some poor soul's gonna look up for Ocaml content like I did over the summer. It'll just be bloons. Stick your glue soap. Save a little bit so I can get a ninja monkey. Bomb tower. Or upgrade the ninja monkey. Or upgrade the glue. Triple arts. Yeah. Probably not best value on investment. But more darts is always good. Upgrade the ninja. White balloons incoming. Yeah, that was. Right. Then I'll probably place my first bomb tower, and I'll put that like here. More range. Time for bombs? You want it? It's yours, my friend. As long as you have enough rubies. Boom. You can call it a .com boom even. Bigger bombs. Yeah. I love my missile launchers. I'm a big fan. More bombs. Is cash. Put down a buccaneer. Faster shooting. Grapes. Oh yeah. Haven't mentioned it? Maybe. Upgrade the one they have. You weigh around 42. Alright. Gonna put down another ninja monkey, like here. Absolutely. Down a spike factory. First super monkey. This is great. Okay. Another super monkey. Absolutely. Always time for more super monkeys. Invest in another bomb tower. All right. 64 of 65, so we're about done. Almost there. All right. There we go. That was 3 times around. Yeah. All right. First, I don't know, proper stream, I guess. I think it went good. Thanks for tuning in, everybody. Even for the Ocaml bits. Really appreciate it. Like, comment, and subscribe. Something like that. I don't know. I don't know how to end these. All right. Bye. I gotta get to my class.